So in the previous video, you have discussed about complex PLDs and field programmable gate arrays. So in field programmable gate arrays, the basic components are the elements which are used are logical blocks, input-output blocks and the memories. So here we'll start with the first basic element is logic block. So here the logic block which is shown in the internal circuit diagram is a slice of Spartan 2 kit which uses Xilinx tool to run the program. So here this slice contains two lookup tables, okay, two carry and control logic and two delatches. So if I concentrate on the internal circuit diagram here, so here the lookup tables has 4 inputs. These inputs are directly connected to the inputs of the logic block. And so another important thing here the lookup tables are nothing but these are a 1 bit wide asynchronous RAM memory which are used to store the known values. Okay, here the lookup tables are used to run any boolean function or the logical functions, whereas the carry and control logic is used to combine the output of lookup tables. Then the output of the control logic is given to the delatches, which is used to store the intermediate results. So this is about a brief introduction about the logic blocks. Here another important thing is that to implement any program, you have to do the synthesis tools, then map with the HDL codes and program the interconnect. Means while running the program itself, the synthesis tools using HDL code, okay, will map the programs and interconnecting wires. So next is input-output blocks here. So input-output blocks is nothing but, so here it is used to interconnect with the outside world. So typically it allows registered or combinational input-output plus it uses a tri-state drivers. So as shown in the circuit diagram, it contains 3 flip-flops, 2 mux, 1 tri-state driver and a buffer. Here the select inputs of the mux are used whether to control the output like registered or combinational. Registered means sequential here. So next is the top of the mux and the flip-flop is used to control the high impedance state of the tri-state driver. Similarly, the middle flip-flop and the mux is used to control the output logic of the tri-state driver. So output logic whether it is logic 1 or logic 0. So if logic 0, pull-up register is used, logic 1, pull-up register is used, logic 0, pull-down register is used. So this is an input buffer which is programmed in such a way that it controls the threshold voltage of this flip-flop and the other characteristics. So here the programmable logic levels has a slew rate. So slew rate depends on the maximum output voltage with respect to time. So that is the slew rate which is controlled at the output of the tri-state driver. So next is platform FPGAs. So platform FPGAs are nothing but they are used for special applications. So special applications which require a particular course like embedded course here, like processor course or arithmetic course or network interface course. If any one specific application is required, then that specific application uses any one processor core or any one arithmetic core. Okay, so by doing this, it will allows us to reduce the cost and it is a single chip solution and avoids the high NRE of ASIC. So specific application is nothing but only when a specific requirement is used, and this platform FPGA is different from normal FPGA to reduce the cost and NRE. So NRE is nothing but non-recurring engineering cost which depends on marketing, product and research. So the next is structured ASICs. So structured ASICs is nothing but it is used to implement simple logic elements. Simple logic elements require fewer components where there is no programmable interconnects. So here if I compare this with the normal ASIC, structured ASICs use fewer number of components to implement a function. It is a final or end product which reaches to the market. So by doing the structured ASIC based on the application, here it uses a lower NRE than the full ASIC design. Then performance is also close to the full ASIC. So again NRE is nothing but non-recurring engineering cost. So this is about structured ASICs which is different from the normal ASIC and uses fewer components to implement particular function. So this is about the FPGA and its basic elements and the platform FPGA and structured ASICs. So if you have any doubts, you can text me the message. Thank you.